Hello student, good afternoon. As I mentioned in the morning that today we will discuss practical. There are many practical. Today we are going to discuss the relationship between force of limiting friction and normal reaction, and hence to calculate the coefficient of friction. We all know the theory of friction. If we keep one block here on the surface, mg act in downward direction and normal reaction acts in upward direction. At the equilibrium state, n equal to m into g. Okay, but on which factor the friction depends? Suppose the external force is applied this side, so frictional force acts in this direction. This is the frictional force, and frictional force is directly proportional to n. To remove this proportionality sign, F equal to mu m into g. This m is the mass of this block. Now, how much force is required to pull this block? That we have to calculate, and that force will be equal to the frictional force. So, in our experiment, what we will do? We will use one pulley here, and on that pulley, one rope will pass. This is one pan of 20 gram. The mass of pan is 20 gram, and this block which is here, it is 30 gram. Now to calculate the weight, calculate the coefficient of friction, this force will be equal to this force. Suppose this force is external force, so it will be equal to the weight, which is weight of the pan plus some weight. Suppose if we put some weight here, that also. So it will be that weight, and that weight we can write in terms of mass. If mass of pan is m and small m is the mass kept up here on the pan, so it will be total mass m dash. So it is m dash g, it is equal to mu into mg. This mu will be m dash by capital M. What is m dash? M dash is total mass here, including the mass of pan, and this m is the mass of wooden block, or if the mass is kept on the wooden block. For example, if I keep 20 gram here, so this will be 20 gram, and already this is 20 gram. So total weight being pulled, how much it will be? 20 I kept now, and this wooden block is already, which is 30 gram, so 20 plus 30. The 50 gram weight is being pulled with this weight. What is the weight of pan? Weight of pan is 20 gram. Suppose if we put some weight here, if I put here 7 gram, so total weight pulling the block will be 7 plus 20. So this will be our 27. So in this case, here we will get 27, and here we have how much? 20 plus this 30, 50 gram. So coefficient of friction will be 27 upon 50 gram, and that will be near about 0.54. This we have to calculate experimentally. So now we will see how to calculate the coefficient of friction experimentally. This is wooden block, as I mentioned, it is of 30 gram, and this is plank over which we will put the weight. It is near about 20 gram. Now if I keep this is called pulley, frictionless pulley, over which this thread will pass, and now this is wooden block, and I have to determine, or we have to determine, the coefficient of friction between this surface and the wooden surface. So this 30 gram is already there. So now if I keep here 20 gram, so how much weight is there? Now it is 20 plus 30, 20 plus 30, 50 gram, it is 60 gram. And in this 60 gram weight is kept here, 30 plus 30. So the system in equilibrium state, and the static friction is acting between these two, this surface and wooden block. Now minimum force required to pull the object. So suppose if you lift, this is what, 2 gram, I need even 5 gram, this is 5 gram. So 5 gram weight I am keeping, 20 gram pan already. Okay, so 20 plus 5, how much it is? 27. And we have to see that whether it is moving or not. So on 27 it is slowly it is moving, and it is moving. Okay, so this is the minimum friction, minimum force required to pull the object. And this, so in our coefficient of friction is what? Coefficient of friction is, coefficient of friction is mu equal to m dash upon m. What is m dash? M dash is 25, and m is what? This is m. This m is what? This m is 30 is wooden block, 30 plus 20, 50 plus 60, so it is 60 gram. So by this way we can calculate the coefficient of friction. There on board I have mentioned something else. Now this is first reading, and by this way you can calculate coefficient of friction. Now again we have to repeat the same process. So same process. Now in this case this 30 gram wooden block is kept here. Now we will use 2 gram of 20. This is 20 gram and one more 20 gram. So how much it is? 20 plus 20, 40 plus 30, 70, and it is in stationary state, and here we have 7. So this is 20 of pan plus 5, 27, and now see 2 gram. So is it moving? 27, and this is 2 more gram. So now it is, see that it is moving. It is moving. So this time there we have 29 gram, and this wooden, this weight is what? This weight is 30 plus 40, 70. So coefficient of friction will be 29 upon 70. By this way we can calculate the coefficient of friction.